Example here, refractive index, we have to find the refractive index of glass with respect to water, which means refractive index of glass with respect to water means from water to glass. Is that okay? So what we can do is, okay, say considering that this is water here and this is glass here. So let me just write it here. Glass. Fine. So water is moving from where? Sorry, the light is moving from glass to water, and we know that glass is denser than water, so it will bend towards a normal. So it will have certain refractive index, obviously more than one. How to calculate that? So yes, we have a formula as such. Say if we have two medium one is glass and medium one is water, the medium two is glass. So we can say in this case, speed of light in that first medium, which is glass, upon the speed of light in the second medium, which is, sorry, I told you wrong. Speed of light in the first medium, which is water, upon the speed of light in the second medium, which is glass. And that is the refractive index of when the light moves from water to glass in it. Is that okay? Irrespective of if it is rarer or denser, yes, if it is denser to rarer, it will bend away. If it is rarer to denser, it will bend towards a normal. Is that okay? Remember. So it has been given in the case summarized part here. You have to make a note of all of these. That refractive index from medium 1 to medium 2 is velocity of light in the first medium upon the velocity of light in the second medium. We have done that. And if we divide the velocity of light here, okay, both the sides here, what do we get here? That is, if you divide the velocity of light in, what is say refractive index of the absolute refractive index. When we say absolute refractive index, it means there is a medium and this is vacuum. This is vacuum and this is a medium here. Now when the light falls from a vacuum to medium, it will bend towards a normal. Simple. So for that, how do we find it out? We have the formula for that, that is speed of light in vacuum, which is represented by C, and speed of light in this particular medium, which is V. Right? Clear? So this is the formula that we have. So what do we do in this case? When we have to find the refractive index of second medium from the first medium, then we will find out the absolute refractive index of that second medium here, right? And find out the absolute refractive index of the first medium. Okay, so what is the absolute refractive index of the second medium? C by V2. What is the absolute refractive index of the first medium? C by V1, like the way we have here. If this is the medium 1, so it will be C by V1. And if it is medium 2 here, so refractive index will be what? That will be C by V2. And when we have to find the refractive index, if we have to find the relative refractive index, that is from medium 1 to medium 2. So this is from medium 1 to medium 2, say like water to glass. Then it will be the absolute refractive index of the second medium, okay, upon the absolute refractive index of the first medium. Absolute means it is the refractive index from vacuum to that particular medium. Is that clear? So you can see refractive index of from 1 to 2 will be equal to, see what is this? This is C by V2 upon C by V1. Okay, so when we do that, say solve it, C by V2 divided by C by V1. So will it not become C by V2, right, into V1 by C? C got cancelled, so what do we get? V1 by V2. So we have got V1 by V2 here. So that is the velocity of light in the first medium upon the velocity of light in second medium. Right, don't get confused. Simply remember, sometimes you may be given the refractive index of the second medium in absolute refractive index and the absolute refractive index of the first medium. So there you have to use this. Right? Is that okay? Or you can see the same thing over here, absolute refractive index from vacuum to that medium, and this is the absolute refractive index of the from vacuum to the first medium here. So remember, if it is refractive index of second medium, right, with respect to the first medium, then it will be absolute refractive index of the second medium upon the absolute refractive index of the first medium. Remember that. Is that okay? This is the best way, but all the time you may not be given with the speeds, right? You may be given with, okay, that there is a refractive index of glass is, say, something, say refractive index of water is, say, for example, 1.5, 1.1, and refractive index of glass is 1.5. Then what is the refractive index what is the refractive index when the light moves from water to glass? So in that case, it will be refractive index of the second medium, which is glass, 1.5, and refractive index of the first medium, which is 1.1. And whatever comes, that will be the relative refractive index. We can call it as a relative refractive index. So this is the refractive index of the second medium. This is the refractive index of the first medium. There it has been mentioned here. Or we can say velocity of light in the first medium upon the velocity of light in second medium. I have discussed this with you so that yes, you remember the differences, and it depends upon what is given to you. Accordingly, you will be able to find the answer in it. So here in this example, they have given the say the speed of light in water is what? 2.25 to 10 power 8. Speed of light in glass is how much? 2.2 into 2.0 into 10 to the power 8. You will get this as a refractive index. And okay, now when we have to find the refractive index of say using the absolute refractive index, refractive index, relative refractive index between water and glass, that is from, we can say, refractive index of glass with respect to water, means the light is entering from water to glass. In that case, that will be refractive index, absolute refractive index of medium 2, which is glass here, upon the absolute refractive index of water, the medium 1 here, right? Got it? So if you do that, it is 3 upon 2, which is the absolute refractive index, 1.5, and the other one is 4 by 3, whatever that value, and you will get the same answer in this case here. Is that okay? So either you use this formula or you use this formula, you will get the same answer. Basically, this is the refractive index of two different media, wherein, okay, it's not say medium 1 may be the water, second may be glass, and maybe something else to something else, but they're two different mediums. It's not from vacuum. This is, remember, the absolute refractive index is always from vacuum or air is sometimes, because air and vacuum do not have a lot of difference between the, okay. So we take either the refractive index from air to that medium, that is called absolute refractive index, or vacuum to that medium is an absolute refractive index, and that is denoted by simply mu2 or mu1 like that, which means is a medium 2 from nothing means vacuum, right? Otherwise it would maybe written as medium 1 or medium 2, something like that here. I think it is clear to you. So fine, just make a note of all these formulas and understand. Any doubt?